Okay, so when you FOIL, you get to here, right? So we FOIL because when you square something, you multiply it by itself, so we get to here. Now, AB and BA, these are products, right? AB and BA. Does order matter in a multiplication problem? Like, is 2 times 3 the same thing as 3 times 2? Yeah, so AB times BA is the same thing. So we can rewrite this as A squared plus AB plus AB. You're adding the same thing to itself, so plus 2AB plus B squared. So right here, this is our first perfect square trinomial pattern. Make sure that this is highlighted, circle, starred somewhere on your paper. And then, depending, you know yourself pretty well, I hope. Either write this down or make a note to yourself. You might not want to write it down if you know that you're going to interpret this wrong. A squared, A plus B squared does not equal A squared plus B squared, right? This is a big, fat no. Make a note of that somewhere, or maybe don't make a note of that if you think that that might confuse you, but we just need to remember these are not equal, right? They're not the same. Okay, so why is this nice? This is a pattern. Patterns save us time, right? Humans are pretty inclined to try to find patterns in most things. So if we put numbers and variables to this, an example could be something like x plus 5, this quantity squared. We could FOIL this, right? We could write this as x plus 5 times x plus 5 and do first, outside, inside, last. That can be time consuming, right? If we simply follow what this pattern tells us, and there's actually even quicker ways than using this pattern, but we still need to know it, is, okay, if you look at here's an A, here's an A, the very first thing we do when we have a binomial squared, you're going to square your first term, so you get an x squared. You get that for free. Notice that at the end you have a b squared, and here's a b, so then the end of it is going to be 25, that's 5 squared, correct? And you're squaring it, so it's always going to be positive. So then what goes in the middle here, you look at 2ab. So all you're going to do is multiply a times b, so x times 5, and double it. So this is a trick, and I typically don't talk a lot about math tricks because we can use them improperly. But if you think about, you have an exponent of 2, and you multiply it, so you think you got a 2, multiply it with 5, multiply it with x. That's actually how you get to this middle term. It's 2 times ab. So 2 times 5 times x gives us a 10x. And if you were to FOIL that out, you get the same thing, right? This is the pattern. So you square your first term, square your last term, and then to get into 2ab in the middle, just think about the x. This is where the trick comes in. 2 times 5 times x gives you that 10x in the middle. This will work 100% of the time, which is really nice. And it also works if we change this pattern, and this would be a second special product pattern, kind of. It's really the same thing. If we did a minus b squared, you could go through and FOIL this, right? Which we can very quickly do on the board. A minus b times a minus b, first, outside, inside, last. First, outside, inside, last would give us an a squared minus ab minus ba plus b squared. So the only difference you'll notice is going to be the middle, where instead of having a plus 2ab, it's a squared minus 2ab plus b squared. Now, you really don't have to remember this pattern. You just need to know the first pattern because you get the other one for free. If you see that it's a minus in the middle, just change your middle term to a negative. So if we change this from x plus 5, maybe if we looked at x minus 7 quantity squared, we think about that pattern, a squared. So you're going to square your first term, x squared. Square that second term. What's negative 7 times negative 7?
49.
It's a positive 49. And then think about it. The middle is 2ab, so 2 times negative 7 times x. The negative takes care of itself, because 2 times negative 7 is negative 14, times x is negative 14x. Notice that we didn't actually have to FOIL at all. So when we're doing these problems, I'm going to put a bunch of examples on the next slide. When we're doing these, don't FOIL, right? Challenge yourself. Do not use FOIL. Go back to this pattern, and if you get stuck and can't FOIL, talk to someone around you, talk to me. We're practicing this idea. It's going to be much faster, much, much, much faster. anybody feeling confident that they could tell us the pattern itself? So if I write a plus b squared without looking at, whoa, is that going to bother anybody? It would bother me, that's what I'm asking. What was it, a yes or no? Okay, we're at least going to go through this example problem. All right. So who can tell us a plus b squared without looking at your paper? Spencer, you know the pattern?
Oh, do you want me to like solve it or?
Right. I want you to tell us what this pattern is without looking at your paper. Luke?
A squared plus b squared plus 2ab.
Yes, but I'm going to change your order. That is correct. I'm going to write it like this because typically if you only have one variable, this will put it into standard form for us. All right, there we go. So let's go through this, and we'll take volunteers, but we got 9 up here, so we should hear from 9 of the 20 of you. Michael, first one.
X squared plus 6x plus 9.
There we go. Square that first term, square the last one. 2 times 3 times x, 6x squared. Next one, Spencer.
X squared plus 12x plus 36.
Square the first one, square the last one. 2 times x times 6 is 12x. Next one. Chris.
20x plus 60.
What's the first term?
$4x
There we go. 4x squared.
plus 16x plus 16.
There we go. All right, next one. Turn.
X squared minus 8x plus 16.
There we go. Let's keep this going. Maria.
X squared minus 20x plus 16.
Anybody else? Tom, go ahead.
9x squared minus 30x plus 25.
All right, so this one, there's just a little bit more going on, right? Square the first one, 9x squared. Square the second term, positive 25, and then 2 times 5 is negative 10 times 3, x is negative 30. Awesome. All right, these are a little bit more challenging as I added 2 variables here or flipped it up. So anybody have part G? Kiana?
9x squared plus 6xy plus y squared.
There you go. Square your first term, square that last term. 2 times y is 2y times 3x is 6xy. All right, part H here. Mitchell?
16 minus 8x plus x squared.
All right. And I'm just going to turn that into standard form. This is going to be the one scenario, the only scenario. If it's a special product pattern, and you didn't write this in standard form on your test, this would be the only time I wouldn't mark you down, simply because you're following the pattern, and it's an easy thing to do. So this would be the only scenario where I would let you guys off the hook, because I think that's fine. Jesse, you got the last one for us?
Yeah.
All right.
16x squared minus 8xy plus y squared.
There we go. Now, remember, when you have 2 variables, you can't have, there's no standard form, really, right? So with part G and part I, it doesn't really matter how you write them. Now, I would just write them how the pattern tells you, so just leave it as is. But there is no technical standard form. All right. So let's look at, that's one thing today. We only have 2 things we want to talk about. Here's the next one. Difference of 2 squares. And now this pattern comes from a plus b times a minus b. I want you guys to FOIL here, see what you get. And as you guys do it, I'll do it on the board. So when using FOIL, I got an a squared minus ab plus ba and then minus b squared, because one's positive, one's negative. Now, these two, are they the same thing? Are ab and ba the same thing? Yes, one's positive, one's negative, which means they add to 0. So we get a squared minus b squared, which is where the mean comes from. Circle this, star this, highlight this. When you have a product of binomials, that the only difference is the operation, meaning one's positive, one's addition, one's subtraction. That's the only difference, then your answer is going to be a difference of 2 squared. Something squared minus something squared, right? That's a difference of 2 squares. So, an example of that could be something like x plus 5 times x minus 5. If you notice, you have the same binomial, the only difference is the operation. Positive, negative, or really addition, subtraction. Then you just go right to, you square what is in the first place, and then put a subtraction sign, square what's in the other spot, and you're done. X squared minus 25. Right? This only works if it's in this scenario, so you have the same binomial with an opposite operation. That's it. All right, so once again, I'm going to put a whole bunch of problems on the next slide. Do not use FOIL. Try to use this pattern, right? So all of, if they look like this, use this pattern. All right, so who has our first one for us? Anton.
X squared minus 29.
All right. Here's our A, here's our B. So you square the first, square the A, square the B, put a subtraction sign in the middle. That's it. Next one. Who's got that for us? Okay.
X squared minus 81.
All right, our next one, we got 10 plus x times 10 minus x. Anyone we haven't heard from yet today? That's
Is it 100 minus x squared?
There you go. Next one, we got 5x plus 2 times 5x minus 2. Everybody we have, I think we've heard from almost everybody.
Well,
Carter, thank you. Waiting for that one.
5x squared minus 4.
Alright, I think could be wrong. I think everybody's on to Emma.
4x squared minus 5 to the second.
There we go. And last one, anybody? Yeah, so
X to the fourth minus 16.
there we go. Alright. So that's